You've likely heard of El Nino in the news, and even if you haven't, it's likely that it has affected you. From droughts and wildfires to flooding, El Nino and its counterpart La Nina have major impacts on people all over the globe. But what exactly are El Nino and La Nina, and why do they affect us this way? Before I can explain El Nino and La Nina, I have to explain what's normal for the climate, or, specifically, how the air and ocean normally behave in the equatorial Pacific Ocean. Although it might seem absurd, it's true that all the worldwide effects of El Nino start in this one area. In the equatorial Pacific, there's a very important band of wind that blows from the east to the west. This wind pushes the ocean water as it blows, causing the water to move from the east side of the Pacific Ocean to the west. This moving water has to be replaced by something, so deeper ocean water gets pulled up from below. This is also called upwelling. Water in the deep ocean is colder than water at the surface. You might have experienced something like this if you've gone swimming in a lake or the ocean and felt shockingly cold water if your toes dipped too low. This means that the water on the east side of the Pacific is colder than the water on the west side. The warmer water of the West Pacific also warms the air above the water, like how the air above a cup of tea or coffee will feel warmer. Warmer air is also less dense or lighter. This happens because when something gets warmer, all the little molecules in it start moving faster, causing them to spread out. Think about how it's easier to run around in an open area rather than in a crowd. All of this means that the air over the West Pacific starts to rise. The opposite happens over the cool East Pacific, overall creating a pattern of air that looks like this. When air rises, it gets colder. This causes the molecules to slow down, and when water vapor molecules in the air slow, they start turning back into a liquid, or condensing out. This water now falls as rain, and the drier air continues making its way through the pattern I drew earlier. When the air starts to sink, it has no more water to rain out. This means that there's usually a lot of rain where air is rising and very little rain where air is sinking. Based on our air pattern, we can see how the West Pacific gets much more rain than the East Pacific does. Now that the stage is set, let's see how El Nino changes this pattern and how that could possibly change the weather across the globe. During El Nino events, this east to west wind that I mentioned weakens, or even reverses, so that it might instead blow from west to east. This means that water is no longer pushed away from the east side of the Pacific, so deep water is no longer pulled up. Now, the water on the west and east sides of the Pacific are more similar in temperature. This causes the air pattern we just saw earlier to flip. Air now rises over the East Pacific and sinks over the west. This means that the east side of the Pacific often gets more rainfall than usual during El Nino events, while the west side of the Pacific is drier. Since there's warmer water than usual in the East Pacific, the overall temperature there is also warmer. I'm going to quickly teach you some new vocabulary to help me describe how El Nino affects this next concept. When we are talking about the atmosphere, areas where air is rising are called areas of low pressure. Areas where air is sinking are called areas of high pressure. Air tends to get pulled in towards areas of low pressure because it needs to replace the rising air. Air is pushed away from areas of high pressure because it needs to make space for the sinking air. Finally, there is another important wind band that El Nino changes. This is called a jet stream. It's a band of really fast wind that flows from the west to the east all the way around the world. There are two jet streams I want us to look at right now. One usually flows over about the middle of the United States, and it's called the Pacific jet stream. This jet stream picks up water over the Pacific Ocean, so it brings rain to the areas it flows over. The other jet stream flows farther north, and is called the polar jet stream. Although both El Nino and La Nina affect both jet streams, I'm just going to talk about how El Nino affects the Pacific jet stream and how La Nina affects the polar jet stream, for time and simplicity's sake. If you want to learn more about how both El Nino and La Nina affect the jet streams and weather all around the world, you can check out the resources that I'll mention at the end of this video. When there is an El Nino event, The unusual low pressure area over the equatorial East Pacific draws the Pacific jet stream in, allowing it to flow farther south over the US and generally shifting its position. This causes wet weather over the southern United States. Generally, because the jet stream flows all the way around the world, this shift in the jet stream is a big reason why El Niño can affect the weather in many different places. These maps show how El Niño often changes rainfall in different parts of the world in the summer versus the winter. Now that we know more about El Niño, let's talk about its counterpart, La Nina. During La Nina events, the east to west wind I talked about in the first section gets stronger than usual, so even more water gets pushed to the west. This means that even more water is drawn up from the deep ocean, making the East Pacific colder than usual. This strengthens the normal air pattern that I described earlier. This strengthening also means that the East Pacific often has less rain than usual, while the West Pacific has more. Additionally, since there's more cold water than usual in the East Pacific, the temperatures there are colder than usual too. During La Nina events, the polar jet is pushed northward by the strong high-pressure area over the East Pacific. The polar jet stream also becomes more wavy than usual during La Nina events, so it flows really far north over the East Pacific, then moves south over the middle of the US. Like with El Niño, this shift in the jet stream affects weather all over the world. These maps show how La Nina changes rainfall in different parts of the world in the summer versus the winter. Although this was just a simple overview, I hope you've learned what El Niño and La Nina are and why we should care about them. Here are some useful websites that you can reference if you want to learn more details about El Niño and La Nina. Thank you!